Welcome to The Debate.
Today, we're tackling a really big one. Where did our universe come from? And maybe even more puzzling, what was here before the Big Bang, if anything?
It's a question that's captivated people forever, really. And science, especially lately, has given us some fascinating, maybe even slightly strange ideas to chew on.
Absolutely. And our focus today is going to be on a central pillar of modern cosmology, the theory of cosmic inflation.
Right. And the debate boils down to this. Does inflation give us a, let's say, satisfying answer for the universe's ultimate beginning? Does it paint a coherent picture of how it all started?
Or does it actually just kick the can down the road? Does it push that mystery of the absolute origin back, maybe revealing even deeper puzzles about whatever came before inflation?
And I'll be arguing that yes, cosmic inflation offers our most coherent, observationally backed explanation for the universe's very early state. It gives us a solid scientific handle on what came right before the hot Big Bang we usually think of.
And I'll be taking the view that, while inflation is incredibly powerful, brilliant even, it doesn't actually solve the ultimate origin problem. If anything, it highlights just how mysterious that true beginning really is.
Okay, so let me lay out my position. The Big Bang Theory, it's undoubtedly our best starting point for understanding the universe's hot, dense beginnings. But here's where cosmic inflation is truly brilliant. It doesn't just slightly adjust the Big Bang, it fundamentally strengthens it. Inflation gives us the best scientific story for how the universe actually got into that incredibly hot, dense state that we observe remnants of in the cosmic microwave background, the CMB. So imagine the universe didn't start with an instant, chaotic bang, but rather with a period of incredibly rapid, exponential expansion of space that was actually quite cold and empty.
Cold and empty initially?
Yes, initially. This massive burst of stretching then sort of slams on the brakes, slows down, and dumps all its stored energy into space. That's what heats everything up and creates all the fundamental particles. The quarks, the electrons, everything that makes up you, me, and the stars. That process kicks off the hot Big Bang phase that standard cosmology describes.
Okay.
And why is this inflation idea so crucial? Well, it neatly solves three major headaches that the standard Big Bang model just couldn't handle on its own. First, you've got the horizon problem. Basically, when we look out at the universe, regions that are incredibly far apart look remarkably similar, same temperature, same density. Under the standard Big Bang, there just wasn't enough time for light or any information to travel between them and even things out. So how did they get so uniform? Inflation solves this because before it kicked in, these regions were incredibly close together, all nicely uniform. Then, wham, inflation stretches them vastly far apart, faster than light speed, preserving that initial uniformity over cosmic distances.
Observations tell us our universe is astonishingly flat on large scales. Any initial curvature it might have had should have become more pronounced as the universe expanded, according to standard theory. But inflation stretches the universe so immensely, it's like blowing up a tiny wrinkled balloon to the size of the Earth. From the perspective of an ant on the surface, it looks perfectly flat. Inflation flattens space-time itself. And third, there's the monopole problem. Standard Big Bang theory, with its incredibly high initial temperatures, predicts that exotic particles called magnetic monopoles should have been created in huge numbers. But, well, we don't see them. Inflation helps here because the universe doesn't start incredibly hot, it starts cold and only heats up after this expansion phase, likely never reaching the temperatures needed to make monopoles in the first place.
Right, it avoids those extreme conditions.
Exactly. And beyond fixing these problems, inflation also, crucially, provided a quantum mechanism for seeding the universe with tiny imperfections. These weren't flaws, they were the seeds of everything. Tiny quantum fluctuations happening naturally in that early inflating space got stretched by inflation to enormous scales. These tiny density variations were the gravitational seeds that eventually grew into all the galaxies and clusters of galaxies we see today. And here's the kicker. The theory made precise and testable forecasts about the patterns these seeds would leave in the CMB. And guess what? Observations starting from the 90s right up to today have validated these predictions beautifully. That, for me, cements inflation as our leading model for what happened right before the hot Big Bang. It fundamentally redefines the beginning, moving us away from a magical point in time to a dynamic, understandable physical process.
Okay, I acknowledge that cosmic inflation is truly an incredibly elegant theory. Its power in explaining the universe we see is undeniable, a huge leap forward. But I really struggle with the claim that it provides a definitive answer to the ultimate beginning. From my perspective, it seems to take that fundamental question of true origin and push it into an even murkier, perhaps more philosophically challenging place.
Murkier how?
Well, take the concept of eternal inflation. This is the idea that maybe inflation, once it starts in some region, never completely stops everywhere. It continues expanding exponentially overall, pinching off new bubble universes like ours along the way, creating this potentially infinite cosmic foam or multi-universe. It sounds grand. Maybe it solves the why here, why now question. But here's the critical point, and it's explicitly mentioned in the material we've looked at. This eternal inflation is thought to be eternal only into the future, not into the past. There's strong theoretical evidence, like the Borde-Guth-Vilenkin theorem, suggesting that inflationary space-time doesn't extend into the past infinitely. It must have had a beginning, originating from some prior non-inflationary state, which itself might have been a singularity. So you see, inflation itself needed a trigger. It needed to start somehow. And our current understanding, as the material points out, gives us nothing observable that gives us clues about what, if anything, caused inflation. We have a precursor to the Big Bang inflation, but that precursor itself needs a precursor. We're just left asking the same what came before question. Only now it's about what came before inflation, not the Big Bang. The ultimate Genesis question feels, well, unanswered, just shifted.
Okay, but shifting it isn't necessarily a bad thing, is it?
Maybe not. But let's go further. The whole idea of a true nothingness before everything, physics itself seems to resist that notion. The material makes this point quite clearly. The universe never truly becomes void. Think about it. Even if you could magically remove every single particle of matter, all radiation, everything we normally think of as stuff, you'd still be left with fundamental quantum fields permeating space. And these fields have an inherent jitteriness, a zero-point energy, because of the uncertainty principle. It's the lowest possible energy state, but it's not zero. So even in the closest thing we can imagine to a physical vacuum, something always persists. True, absolute nothingness, no fields, no energy, no physical laws, no space, no time. It just lacks physical reality. We can't even design an experiment to create it. So my point is, while inflation does a beautiful job explaining the how the universe got hot, how it got structured, how it became flat and uniform, it seems, it completely sidestepped the deeper why. Why did inflation start? Where did the inflaton field itself come from? What about the quantum rules and physical laws that allowed it all to happen? The idea mentioned that maybe the universe is just a giant virtual particle bubbling out of quantum uncertainty. Well, that points to a much stranger, more fundamental origin story that inflation, as powerful as it is, doesn't really address. It explains the expansion, but not the ultimate source.
Okay, understand the concern about the ultimate origin, but let me offer a slightly different angle here. Maybe inflation isn't just deferring the beginning. Maybe it's fundamentally redefining what we mean by a beginning in a scientific, physical sense. Look, the old Big Bang model, without inflation, pointed back to this mathematical nightmare, a singularity, a point of infinite density, infinite temperature, where physics just breaks. It's unphysical. Inflation, this period of rapid expansion, elegantly avoids that specific singularity right before the hot Big Bang. It doesn't necessarily mean absolute nothing existed before, but it presents a physically plausible state, this cold, expanding space dominated by field energy that precedes the hot phase. It moves us away from an instantaneous, maybe even mystical, creation from nothing to a dynamic process we can model with physics. This is the most robust scientific description of an initial state we currently possess. It's a redefinition based on physics, not just kicking the can.
That's a fair point about avoiding the classical Big Bang singularity right then and there. And yes, that is a huge success for inflation. And this is where I still hesitate. While it sidesteps that specific singularity, it doesn't seem to eliminate the need for some kind of prior state, or even a deeper, earlier singularity. The research we've both seen explicitly states that inflationary spacetime doesn't extend into the past infinitely and must have originated from a prior non-inflationary and possibly singular state. Doesn't that simply mean we've swapped one beginning problem for another one, just pushed it further back in time? We've replaced the immediate Big Bang singularity with a pre-inflationary one. We still have an incomprehensible starting point, just earlier. Have we truly explained the ultimate origin or just shifted the mystery?
But isn't pushing the problem back, replacing an unphysical singularity, a breakdown in our math, with a theoretical precursor state, isn't that scientific progress in itself? I'd argue it is. We now have a different kind of question to ask. What could have triggered inflation? What was that prior state like? These are questions that might, just might, be addressable by future physics, maybe string theory or quantum gravity, in a way the old singularity wasn't. We're talking about a physically distinct beginning of our observable universe, a specific state we can model, the state from which everything we see actually emerged. That feels like a meaningful advance.
And the timeline. But the fundamental question was about the ultimate beginning. And if we keep needing a before, are we really getting there? You call it a physically distinct beginning, which I understand in terms of the transition. But I'm still stuck on this idea of nothingness. Can even that pre-inflationary state truly arise from absolute nothing? As we discussed, physics seems allergic to true nothingness. Quantum fields, zero-point energy, they seem to be fundamental. The material says the universe never truly becomes void. Even if we imagine this pre-inflationary state as incredibly simple, it still seems to require something. The laws of physics, quantum fields, the potential for inflation to happen. If that something always exists in some form, doesn't that make a true beginning from absolute nothing seem like, well, maybe not a physical possibility? Maybe it's a philosophical concept, not a scientific one.
Okay, I see the distinction you're making between physical beginning and philosophical nothingness. Let's focus on the physical beginning, the start of the universe as we know it. While sure, absolute metaphysical nothingness might be beyond physics, inflation describes a physically distinct state that is dramatically different from today's universe. It's this cold and empty, exponentially expanding space dominated by the energy of a quantum field, the inflaton field, not by matter or radiation like now. It's not nothing in the absolute philosophical sense you're pushing for, perhaps, but it is a concrete, scientifically modeled precursor state. The crucial thing inflation offers is the mechanism for the transition from this very specific, very strange physical state to the hot, dense, structured universe we inhabit. Understanding that transition, how that state could evolve into everything we see, that's a profound leap.
It is a beginning in a very meaningful physical sense, the beginning of the universe we can actually observe and test.
But is it the ultimate beginning or just a phase transition from a different, perhaps even stranger kind of something? If the inflating field itself and the quantum mechanics that govern it had to exist before inflation could start, well, then we're still left asking where they came from. We haven't explained the origin of the fundamental ingredients, just how they cooked up our particular universe. To me, that still pushes the ultimate question back to the origin of the fields and the laws themselves, not just the transition from cold inflation to the hot Big Bang.
Well, let's talk about evidence. The predictive power of inflation is, I think, its strongest card. It didn't just explain away old problems, it made precise and testable forecasts, predictions about the exact patterns of temperature fluctuations in the cosmic microwave background, the nature of density variations, the overall geometry of the universe. These predictions have been validated by observations spanning from the 1990s to the present day. We see the near-scale invariant spectrum, the adiabatic perturbations, exactly what basic inflation models predict. This empirical confirmation, this matching between theory and detailed observation, gives enormous weight to inflation as our most accurate picture of those earliest moments. We have concrete evidence of its effects. It's not just a neat idea, it's rooted in what we actually measure in the sky.
And I absolutely agree. The observational evidence confirming the effects of inflation is stunning, revolutionary even. The CMB data is beautiful, precisely matching the predictions for how inflation seeded the structures we see today. No question. However, and this is a big however for me, we need to be careful about what that evidence actually confirms. Those incredibly precise observations correspond to just the final tiny fraction of a second, maybe 10 to the power of minus 32 seconds, before inflation ended and transitioned into the hot Big Bang. So yes, it gives us an amazing snapshot of the very end of inflation and its immediate consequences. But the material we've looked at is also quite clear. There's nothing observable that gives us clues about what, if anything, caused inflation. The evidence confirms the results, the aftermath, but the trigger mechanism, the actual initiation of this whole process, that remains entirely theoretical. There's no direct observational probe of that initial moment, and that's a crucial distinction when we're talking about the ultimate beginning, isn't it? We see the smoke, but we didn't see what lit the fire.
But hang on, to dismiss the whole theory or its claim to describe the beginning, simply because we can't directly observe the absolute first instant, isn't that setting an impossible standard? By definition, any scientific theory of origins deals with a time before anything could be directly observed in the way we observe things now. What inflation does provide is a coherent, physically sound pathway from a specific kind of initial condition to the universe we can and do observe. It solves puzzles along that pathway. The fact that its predictions for the observable consequences, the CMB patterns, galaxy distribution, are so stunningly accurate provides powerful, indirect evidence for the whole inflationary picture, including its initiation. We infer the beginning from its incredibly precise and verified consequences.
Oh, I'm not dismissing the theory at all. Its explanatory power for our universe's structure is immense, truly. What I'm questioning is whether it fulfills the promise of explaining the ultimate beginning. While we can infer consequences, the complete lack of any observable handle on inflation's cause means we're left with a pretty significant gap in the story, right at the start. It feels a bit like, finding perfectly preserved dinosaur footprints. We can describe exactly how it walked, its stride, its weight, but we still have absolutely no fossil evidence of how the very first dinosaur egg came to be. We understand the dynamics incredibly well thanks to inflation, but the true genesis moment, that primordial state before inflation, that still seems to completely elude our grasp, leaving the fundamental why of it all just as open, just as mysterious as ever.
Well, reflecting on this, I think this discussion really highlights that cosmic inflation, deeply rooted in observation and theoretical consistency, genuinely offers our most sophisticated, most complete scientific explanation for the conditions that directly led to the hot Big Bang. It masterfully resolves those critical paradoxes that troubled the older model, and it provides a solid framework for understanding the universe's immediate past. It moves us significantly closer, I believe, to a profound understanding of how our specific observable universe came into being. It presents a coherent, physically plausible start for everything we see, even if the absolute first cause remains that tantalizing next step.
And I'd say, while the explanatory power of inflation for the evolution right after the beginning is undeniable, this conversation also really throws light on the profound limits of what we currently understand about an absolute beginning. The research strongly suggests inflation itself needed a starting point, possibly emerging from a prior singularity, and that the universe, at its most basic level, seems to fundamentally resist true nothingness. Quantum fields, zero-point energy, they just seem to be. So for me, the question of what actually kicked off inflation, or the nature of that primordial state it grew from, remains a deeply compelling and very open mystery. It clearly invites much deeper scientific and, frankly, philosophical thought that goes beyond even this incredibly successful theory.